It's another problem is that when you do these patterned exercises, these named patterned exercises, immediately when you give someone an exercise and you give it a name, understand that you're now programming them to get better at the named exercise, not to get better at themselves. So if I put, you're going to do squatting. When you squat and I tell you how to squat and I say chest up and I say knees out, what I'm saying is I want you to replicate the squat in the exact way that my verbal cues are telling you to replicate the squat. So then you go ahead and replicate the squat. Now, based on muscle physiology, we know that when you replicate a movement, the way the muscles contract become patternized. What do I mean by that? People have this weird concept that a muscle does something. And a muscle doesn't do something because a muscle isn't really a something. A muscle is a mouth noise that we use to describe a large area of tissue. In other words, if I take a muscle, so on the outside of a muscle, you're going to have the paramecium, which is the outer connective tissue or fascial encasement of the muscle. And then inside that muscle, you're going to have a separation of what we call muscle bundles. In these muscle bundles, they're surrounded by what we call paramecium, which is the connective tissue encasements of these bundles. And then in every single bundle, you're going to have thousands and thousands of individual muscle cells. Okay? So here's a bundle with all of the muscle cells. I'm looking at this as if I'm taking, let's say, the bicep and I'm cutting it transverse so that you're looking straight onto the bicep. Now, so you have all of these bundles, and all of these bundles have all of these muscle cells. Now, we know this to be a muscle. We say this is the bicep, and we say weird things like the bicep does this or the bicep does that. But if you look at the current literature on muscle physiology and how muscles contract, and if you look at the intermuscular force transmissions, the intramuscular force transmissions, the literature regarding those, it's very difficult for me to tell you that a muscle has a particular task or a particular function because you don't contract a muscle with the all or none principle of human physiology. What do I mean by that? There's a principle in human physiology called the all or none principle of muscular contraction. And what it states is that when you neurologically discharge to a particular motor unit, the entire motor unit has to contract. So it's all or none. So when a signal goes out to a motor unit, the entire motor unit contracts. What it does not say is that when you send a signal to a muscle, the entire muscle contracts. A motor unit is not the same as a muscle. A motor unit is an innervating nerve plus the few muscle fibers that it innervates. So this particular motor unit, I'm going to demonstrate as innervating 4 muscle fibers, and that is one motor unit. When I contract this motor unit, when my central nervous system tells this motor unit to contract, all of these fibers must contract. That is what the all or none principle demonstrates. It doesn't say that the entire muscle should contract. So what does that tell us? That tells us that the muscle isn't a something. The muscle is thousands of somethings because every single muscle fiber or muscle cell in its own right is its own muscle. It has its own strength-strain curve. It has its own machinery for contraction, etc. So every single one of these muscle fibers is its own muscle. Now, we go back to this idea of squatting. And I realize I said this was the bicep, but you can very easily just substitute this with the quadricep muscles of any, whichever one you like the best. When you do a squat, you don't contract the entire group of quadriceps at the exact same amount or intensity. What happens is when you patternize an exercise, the same motor units are going to be utilized. So you might use these motor units for your particular squat, and then if I go to the neighboring bundle, maybe you're going to use this one, and this one. And then in the neighboring bundle, there's going to be another few muscle cells that you're actually going to contract. All of these other ones are not going to contract. So I'll just go ahead and erase these ones that are not contracting. So now, when you look at a total muscle contraction, that's what contracts. So in this particular example, these fibers, these cells, and those cells. Now, If I change the pattern, if I tell you now I want you to put your leg another 30 degrees into external rotation or 10 degrees into internal rotation, however I change your body position, I'm going to change the way the muscle contracts. So now in the new body position, when I say squat, instead of contracting these fibers, you might contract these fibers. These ones are no longer being activated, and now you're using this motor unit. And then on this muscle, instead of using the ones that we have there, maybe you're only using a few of those cells. And then on this one, you're going to ramp up some more cells in this direction. All of these different muscular combinations will pull at very different angles on the resulting tendon. Because of that, it's going to pull very specifically on the joint that tendon is affecting. So now we have the muscle is going to contract very specifically. Only the tissues in the surrounding area will take the immediate force from the muscular contraction. Those forces will bleed into other areas of the muscle, but it's not the entire muscle. In other words, when you ask someone to patternize, you're using the same physical material over and over and over and over and over and over and over again. Now, if you think of the adaptation capacity of an individual muscle cell, you have to conclude that it cannot adapt indefinitely. So if you're running the same pattern, you only have a few options for those motor units along that path. The motor units are going to adapt, hopefully, to your stimulus, but they're only going to adapt to a point, and then they're going to either plateau or they're going to get injured. As soon as you've exceeded the amount of adaptation that can occur, that's when you reach the upper limit of your ability to produce force or your upper limit of your ability to perform. Going back to the bench press, if you're doing a bench press and your coach tells you have to do the bench press this way every time, those cues only make sense if your job is the replication of bench pressing. Because if it's not, and you're told, I want you to bench press with this body position all the time, then what your coach is saying is, I want the same tissues to be stressed along the same lines that we've always been stressing them on. And now that you're getting stronger, we're going to start to up the weight. That's why you see people have been bench pressing for years. You would think that they would just, 10 years ago they were bench pressing 1 plate. They should be at 6 plates by now. But it doesn't happen that way. They kind of fluctuate. They go up, they go down, depending on injuries, depending on cycles of training, and depending on the ability to maximize the amount of adaptation that occurs in a particular pattern. You can't adapt more than you can adapt. That's a rule. So if you're stressing the same patterns, then you're adapting the same patterns. And if you're patternizing someone and you're making them stress the same tissue, when you exceed the ability to adapt, that tissue has no choice but to yield or become injured. Other things that will happen is accommodation. The muscle will learn how to do the pattern easier. But again, where are you spending your time? Going back to the jiu-jitsu player, where are you spending your time? Is your time best spent using your maximal neurological efforts to replicate the pattern of squatting? Or is it better to replicate a pattern where you need your body to produce max efforts? If you're a jits guy out there, when was the last time you trained the squeeze? Now, don't tell me that you rolled and then after your roll, you got someone in a rear naked or in a darce or whatever, and you tapped them, because that's, arguably 10 to 20 seconds of muscular activation. But when did you solidify that pattern? When did you take the time to lay down tissue to strengthen the pattern that is squeezing so that you can maximize that adaptation capacity? And the thing is that I don't see that in training. If I see it in training, I see it sporadically because those exercises don't have names. It's easy to go to the gym and say, what am I doing today? I'm going to squat, I'm going to bench press, you're going to say the words, the mouth noises that have been given to you. But as a martial artist, you have to execute strength in a variety of different ways that don't resemble these patterns, these mouth noises. So in GPP, you have to maintain those capacities. And if you're not programming them, then you're not maintaining them. If you are programming it, often people program it with regards to their dynamic work. So they keep their maximal effort contraction for deadlifts or for bench press, and then they'll do a few reps of squeeze. Maybe if you're jiu-jitsu instructor, maybe they do it during class, so you might warm up with squeeze, but it's not enough. It's not programmed. You're not doing it intensely enough. You're not treating it like a deadlift. So you're not getting all of the endocrine benefits, all of the neurological benefits from training a max effort, because people don't think it's max effort because you're taught that max effort has to have this patternized name. So to summarize, if you're an athlete, you have to almost stop thinking only sport specific, and you have to start thinking tissue specific. Where do you need more tissue to be laid down? Where do you need the ability to produce or accept or dissipate force? And then you got to really concentrate on putting stuff in those areas. If you just keep backing up these patterns, again, unless your job is deadlift, unless you're a power lifter and you're squatting for weight, I believe that you're wasting a lot of your time. And as I said at the beginning of this, your training time is very precious.
Hey, Dre.
Yes, sir.
I have a question.
We have Mark behind the camera. And
hi, it's Mark Brunswick, your producer of Control Yourself.
Okay, so what's the question?
So the question is, I immediately get the connection to jiu-jitsu as I practice it. So for somebody who, say, does Muay Thai or a striking sport, can you give some examples of what the crossover, the translation would be for this max effort training?
Brilliant. Okay, so this is my realm now. We're in the striking realm. So it's the same thing for a striker, and this brings up a whole another conversation here. Because so let's say when I'm doing my bag work, there's two different modes of bag work. I'm doing bag work to practice skill, and then I'm doing bag work so that I can stress the tissues that I use for throwing kicks and punches. Okay? That's max effort work. So when I go to do a bag session, sometimes my bag session is for physical training, and sometimes it's for skill. When it's for physical training, I'm gonna put in spinning back kicks at 90 to 100% intensity for a certain number, just like you would do in the gym for bench press. You'll say 5 by 5, whatever. For max efforts, you might say 3 reps for 4 sets at as much as you can do, or 90% of what you can do, or above 90% of what you can do. But when I'm doing spinning back kicks, when I hit a bag, that's 100% of what I do for that particular technique. So that is my max effort work. So now I can put max effort work with spinning back kick, and then I can couple that with dynamic effort work for muscular strength or generalizability. But to say that I'm going to do max effort work in a squat is to say that it's not going to transition over as well as it is when you're actually doing the kick. But you understand what I'm saying. It goes back to the idea of patterning and where are you trying to lay down the most amount of tissue. And that brought up another point, and I hope I'm not jumping around too much, but they often say, and I've heard this all my life, because as you know, I started with Taekwondo, I went to Kempo Karate, I went to Muay Thai, so I've done a lot of different striking arts, and I always hear that the Muay Thai kick is the strongest kick. Now, I'm not going to argue that it's in general, people who study with Muay Thai tend to have stronger kicks. And I don't want to argue the mechanics of it, because throwing a leg kick, just by the mechanics of it, it's gonna be easier to put more weight behind. When you do it in the Muay Thai way, I understand the mechanics of it, that you're swinging a baseball bat versus the bending of the knee and the flicking out when you see in Taekwondo kicks or in karate kicks. It's just a different hinge. So forget the argument that the kick probably has more force behind it just because of the mechanics. What's more important and what people forget is that Muay Thai gyms train the kick at max effort repeatedly. So they use the bag as a training device. They go to the bag and they say, I'm doing 100 swing kicks. And they do that, let's say, 2 to 3 times a week. That's max effort work for them. If all you're doing is hitting targets, or when I was younger in Taekwondo, we'd have those kick pad targets. Again, that's a skill training session. And what you don't see as much with Taekwondo practitioners, with karate practitioners, Hapkido, or any of these other things, is you don't see them using the bag as max effort training. So the kick is stronger, sure, but the tissues that are along the pattern of the kick have been reinforced with max effort training for way, way longer with Muay Thai practitioners, which might be one of the reasons why we ultimately say that the Muay Thai kick is that much stronger. Does that make sense?
Absolutely.
Did I answer the question?
Yeah. So
okay.
This is a missing piece in the other striking.
It's a missing, yeah.
So in theory, you should be doing, if you're doing a front snap kick, you should be doing a max effort front snap kick.
At some point.
To make that better.
At some point. I mean, you can also break up, if that's the quality that you're looking to improve, then I should see that max effort. It has to be done appropriately. Some people don't even have the stiffness or quality of tissue necessary to withstand heavy bag work, which is another reason I hate. You know what I hate is that cardio type kickboxing things. I don't hate it because it's not. It's fun. I get it. It's fun to do, but you're taking people who are not prepared. It's like, would you start with plyometrics? You would never take a beginner and say, we're going to do box jumps before you do one-legged squats, bodyweight squats. But if you take someone and you put them in a cardio kickboxing class, what you're saying is, I want you to plow into this bag as hard as you can. So not only are you going to explode, but you're going to decelerate at an extraordinarily high rate, which is going to put an incredible amount of force into your tissue. And most people's tissues don't have the force dissipation capacity to be able to withstand. And then they hurt themselves. And of course, we blame it on whatever we blame it.
Technique.
We blame it on technique, or you didn't drink enough water, or you haven't been squatting enough. As if squatting is going to reinforce the exact line of tissue that you need. I mean, now you're looking back at this and you might say, yeah, but if you're always working the same pattern for kicking, then you're going to patternize as well. And you're right. I get it. These things have to alter, right? There's GPP where there's certain qualities you have to keep, and then you have to fluctuate what you're doing, or you're always going to run into that problem. But to call my patternizing out when we can go into this gym and watch people doing, lat pull downs ad nauseum for 17 years. I mean, the patterning going on there is far worse, right? Those tissues, the tissues that you're deadlifting with, trust me, they've been trained enough. Like, if you think of the volume of training you've put on the specific tissues you use to deadlift with, it's probably fucking high, right? Like, a lot. How long have you been deadlifting? When you think about it in these terms, when you think about taking an athlete and finding new areas to stress, when you think about expanding range of motion, this is where people get confused into thinking that my system's only about mobility. It's not. It's about exploring the body to look for new lines of tissue with which to adapt so that it can ultimately produce or accept more load. So it's searching the body for the ability to add more, to adapt more, as opposed to waiting for these patterns to fail and waiting for these patterns to ultimately destroy the tissue. I think that's a good place to leave it, but on the next whiteboard session, maybe we'll talk about the tissue itself. I mean, this was good for muscle, but there's a lot more of this story where if we can take this muscle three-dimensionally and bring it out into a tendon, and then tendon to ligament, ligament to capsule, capsule generally to the preservation of space, which is the joint, that bioflow understanding is necessary to really understand what I'm trying to get at to its fullest depth. So our next whiteboard session, maybe we'll talk strictly about bioflow and about how conceptualizing the human anatomy in terms of bioflow is a much more effective way to conceptualize the functionality of human anatomy. But anyway, that's it for this whiteboard talk. Thank you guys all for tuning in, and we will see you next time.
I'm gonna go squeeze something.